Hello everyone, welcome back to my tutorial for the full stack developer series. And this video we will talk about something super important in coding, the solid principles. So if you are into clean, maintainable code, especially as a full stack developer, this is your bread and butter. So what is solid? It's an acronym for 5 design principles here that help you write better object-oriented code. So they are, you can see here, the list of letters. The S stands for single responsibility. The O is open or closed. The L is Liskov, substitution. The I is interface segregation. And the last one, D, is a dependency inversion. So the last one is very important, that the Spring support us. But before we use Spring, we will create by ourselves to understand more about this technique. Okay. So now we just go to every single one, okay, to understand in detail for them. All right. For the S, the first one is a single responsibility principle. It means every class or module should have just one job. Why? If a class does too many things, it's harder to change later without breaking stuff. For example, imagine okay, let's go to product. Okay, we have a product class. So the product class should only handle the product data. Okay, don't only handle the product data, like it holds the data like ID, like the name of the product and something like that of the product. And the product cannot do something like create product or update product, or a service like buy in a product or something like that. Okay. Those jobs should be moved to a product service. Okay, like here we have a product service here, and we have too many business, too many logic of get the product list, get the find the product and create a product, and maybe in the future we have something like buy in product or do something like that. So the root cause here is that just separate the class, okay, and keep every class focused on its responsibility. Okay. All right, and the next one is open or closed principle. So it means classes should be open for extension, but closed for modification. So fancy, right? But it just means you can add new features without rewriting old code. For example, we have a service for payment. For example, a payment, right? And this payment have a method like do payment. Okay, and okay, do payment with cash, for example, with cash. And if you want to add credit card payment, you can do this, right? Or do payment with credit. In some case you will do something like this, right? But it will be violate from the solid principle, because the solid says that you need to extend, extend, not modify. So to do that, you need to create another service for the payment. You need to create a credit payment, and then you extend the payment, okay, and you write the new method public void do payment with credit, like this. Okay, just extend it with the new class, instead of tweaking the original. Okay, yeah, okay, and the next one is the Liskov substitution principle. This one says if you have a parent class, and any subclass should work perfectly when swapped in without breaking the program. It's hard to understand, right? But let me share with you an example so that you can understand more. So let okay, just remove this to okay. So for example, you have a class named bird, okay, and the bird has the method fly, okay, the method fly. And if you have a subclass named eagle, okay, eagle is a kind of bird, right? You can extend the bird, and you can override the fly method like this, right? The eagle should fly 5, right? And in some case you see this message, okay, message, because the eagle also can be able to fly. But if you create a Java class named Backend, yeah, it also in animal it also a bird, but just do this bird, and when you override the method fly like this, you see the Backend can't fly, so it shouldn't break the code expecting fly. Okay, so you see when you do this, you see it's weird. Backend cannot fly, so when you create an extension like this, it's not good. So don't do this, don't create something like this, okay? Or okay, and I think yeah, that's it for this, because it's not very important, so I think we can move to the next one. Is the is interface segregation principle. Okay, let me remove them first. Alright, so the interface segregation means that you don't force classes to implement stuff they don't need, yeah, keep interfaces small and specific. For example, you have an interface iWorker interface, and in this you will create a method work and a method eat, right? And now you in the moment we just have worker is the human, right? The worker now is human. Worker, you can create a worker class and extend or no, implement the iWorker, and you need to implement all the method work and eat, right? And maybe in the future you will have some worker not human, for example the robot, right? And now you also implement from the worker, and you implement all the method in the worker. So you see the robot, yeah, the robot can work, but doesn't robot eat? No, robot cannot eat. So you see that this implementation is not good, right? Robot shouldn't implement the eat method. So just split it into two interfaces instead. Now you instead of create an instance robot, you need to create an interface name workable, and just create a method work. Okay, and another interface is it able, and just has the method named eat. And now when create a worker, you can implement the worker workable, and the eatable like this, and so that you have a worker can work and can eat. And the robot, now you just implement workable. So now you just implement the method work for the robot, right? Cleaner, right? Okay, so that is the interface segregation principle. Now just remove. Okay, and the last one is dependency inversion in principle. So dependency inversion principle means high-level modules shouldn't depend on low-level details. They should both rely on abstractions like interfaces. So for example, you can see in the previous example, the previous video, we have created the here you see, yeah, you see in the controller, when we use a service, we just create a service with the definition from an interface, right? We don't use just product service like this. We use a principle, we use an interface product service. So that's why we you see the product controller doesn't depend on the low level. The low level means the product service, okay? But we just depend on the interface, not depend on the product service. So why we should do that? Imagine that someday you don't want to use the current product service here. We don't want to use this again, okay? You need to modify it to, for example, you create another name product service v2 like this, okay? And to force the program use your new product service, you don't need to change anything inside the controller. You don't need to change it inside here. You just change the configuration of the print of the string. Just remove this for the old one, product service, and then when your program runs, it just auto write the instance of product service v2 like this, okay? That's why, because you are in the controller, you use the interface. Just notice that here is an interface, not the real class product service. So you can say that product controller doesn't depend on the product service. This is the low level module, but it depends on an interface named iProduct service like this, okay? So that is the dependency inversion principle. All right. I think that's it for this video, and if you have any question, please comment below. I will answer you in more detail so you can understand more. And if you like the video, please click the button like and subscribe the channel. I'm very happy for that. Yeah, thank you and see you in the next one.